How do you think large models used to understand human characters? My wife asked me a few days ago, and I told him that the large model will represent each word with a number, so that predicting the next word becomes doing another set of elementary school calculation problems. As long as you keep doing calculations later, he can keep outputting text. After listening to it, he seemed more suspicious. But the meaning of a word is so rich. How can numbers express all these rich meanings? If it can represent both a fruit and a company, how is it complicated with numbers? So I decided to explain it in another way. Let's first assume that the word king is used with one to represent the word queen, and whether it can be regarded as the two words being exactly the same in a certain dimension, such as status. Of course, it may also be in other dimensions. If the word queen is expressed by 2, it means that these two words are different in some dimension, which may be gender. Now we start to use two numbers to represent each word. The king is 21 and the queen is 22. Can it be regarded as they are in a certain dimension? It's the same, but it's different in another dimension. You can use one more number to describe each word to describe the difference between them in more detail. Then let's add two more words now. The word man is the same as the king in gender, both of which are 1, but the status is different from the king. The word woman is the same as the queen in gender, but the status is the same as the man in status. Interesting things happen. You will find that the king picks up the man and the woman is exactly equal to the queen. So, calculating the repeated addition of 1 in status equals 2, and the repeated addition of 2 in gender equals 22, which coincidentally represents the queen. Using two numbers for each word allows us to simulate the difference and mutual relationship between these four words in a two-dimensional space with basic arithmetic. Introducing more numerical representations, such as 3 sets of 10, 100, and 1000 numbers, can provide a more detailed multi-dimensional description of each word's interrelations. What is a large model? In GPT-1, each word is represented by 768 numbers, missing 7 decimal digits. In GB2, each word is represented by 1600 numbers. In GB3, it is 1288 numbers. In DeepSeek v3, 7168 numbers are used to represent each word, but the large model will not tell you what each number means, although each number definitely represents. Or the attribute is used to represent the bunch of numbers for each word. Professional numerical language is called words. In English, it is called embedding. Why do you need strange names? You see, just now we used two numbers to represent a word. Can these two numbers be regarded as a two-dimensional coordinate or a two-dimensional vector? Then using two numbers to represent a word is equivalent to cutting the word into a two-dimensional plane. And using three numbers to represent a word is equivalent to pulling the word into a three-dimensional space, using 7160. In terms of numbers, each word is equivalent to putting the word into a 7168 dimensional space. However, I can't draw it, and you can't imagine it, but it does exist mathematically, which is why it is called magnetic entry, because a word is really owed into a mathematical space. How is the value of each word determined? At the beginning, it is equivalent to all the words being randomly scattered in a space. At the stage of the large model, each word will be packed into the most appropriate position according to the distribution pattern of a large number of words that humans have. Words with similar words are usually closer to each other after some training, and the positional relationship between them can reflect the meaning relationship between them, even if the previous example. And the quality of a word is determined by its relationship with other words. For example, when we explain a word, we will use many other words to explain it, and it is necessary to use other words to explain what he uses. Hey, if you go back and forth like this, you will finally find that the words and this language are interfaced with each other to form each word, so the spatial positional relationship can reflect the meaning of each word. The more numbers you use, the more detailed the description is. It can represent both a fruit and a company brand. So is the position of his word signature on the fruit side or the company side? Neither of them or all of them at the beginning. He was in an intermediate state, just like Dinga's cat. When he and other words appear together, they will change their calculations with each other, and her original value will make him become a more specific one. For example, when a word eat appears in front of an apple, the word eat will be calculated with the apple, and the value of the word apple will be updated to the apple representing the fruit. If Apple updates a mobile phone or company later, these will also be calculated with Apple, and the word Apple will be updated to the value specifically referring to the company brand. So, looking back, how do large models understand words? Behind every word is a lot of mathematical calculation.